Hi, everyone. We'll just get started in a couple of minutes, but if somebody in the chat could just let me know that they can hear me, that would be really good. Awesome. Thank you, Avi. Questions in the chat observed with the recording. So if you give me a means to follow up with this later, I will do that if you put a question in the chat window, or you can seek me out on LinkedIn. And if you do send a request, you window.
Sorry, Dan. We cannot hear you. Can you hear me?
Can you hear me now? Okay.
Yes, Dan, we can hear you.
Okay. Right. Terribly sorry about that. Somebody said that they could hear me when I started the meeting, so I don't know why it stopped. Okay. I'll have to kind of rush through this then a bit. So basically, I'm not sure how much you missed, but essentially, an event means that something's happened, that someone wants a notification about it, and that notification typically triggers an action or a reaction, and it's based on facts. And the important thing about that is that the facts are generally pretty lightweight. It's generally about metadata, not a whole lot of data. And later on in the presentation, I'll talk about the difference between messaging and eventing. And there are two kinds of events. They can be discrete or they can be series-based. So an example of discrete event means that the event in itself, a single event, is significant and is actionable. An example of that would be a file gets created in a directory somewhere. So whoever's interested in that file, they just need that one notification about the file and they can do whatever they need to do with it. Series-based events are different in that the meaning of that event and the significance can only be derived from that event within the context of other events around it. So think about anything that you might want to plot on a graph, right, over time. An example I can think of that would be an IoT device measuring the temperature in this room, and it reports a temperature of 25 degrees Celsius. That event in itself is not terribly significant, but if in 2 minutes' time it reports an event of 28 degrees, and in 5 minutes' time it reports an event of 33 degrees, that becomes significant. So with series-based events, you need to be able to analyze events over a partition, a time-based partition, and analyze to derive the meaning of that context. And because of that, that determines what kind of eventing platform that you use. That makes a difference then. Also, briefly, I'll just talk about the difference between event-driven, which is what this talk is about, and event sourcing. So event-driven means that it's notification-based, that something is reporting a bunch of state changes, and that the consumers of that can react or deal with those state changes as they wish. And it's completely decoupled. The publisher and consumer generally don't even know who each other is. Event sourcing is a bit different, where the event itself actually becomes the critical data in an application. This is useful in auditing type of situations, and it relies on the ability to replay those events. So you can basically reconstruct the state of something by replaying those events. And again, that also dictates what kind of a platform that you can use for that. So why event-driven integration? What are we interested in with that? So we have APIs all around us. Everything that we're building today generally is API based, and we've got data emanating from everywhere, from IoT devices, from social media, and we need to have a way to maintain data consistency and tie those together. Now, about 4 years ago, Gartner reported something they called the Copernican shift, which is where in the traditional application, the center of everything was the data store. That was the source of truth, and everything was about persisting data. Whereas more recently, in event-based paradigm, the events themselves are actually the important thing, and the reaction to those events is the first priority of the persisting data. So event-driven integration helps with that. Also, we live in a world now where we want everything in real time. I'm sure many of you would have had the experience of when you've placed a large charge on your credit card or made a big withdrawal, if you get a text message on your phone from your banking app that says, hey, this large charge has been made. And that's obviously the bank trying to protect against scams. If you were to receive that notification the next day because of a batch process running overnight, it probably wouldn't be very useful to you. And especially today, we got news coming from everywhere. We want to know about it when it happens, especially in the world of COVID-19. So we need that to be real time, and event notifications enable that to happen better than batch processing or even publish subscribe to a certain degree. And mentioning publish subscribe, in a traditional integration model where we have decoupling between the publishers and the consumers of the data, one of the typical mechanisms for that is either a queue or a topic. The publisher publishes something on the queue, and the consumers then pull that off through a polling operation. Now that works very well. It's pretty scalable, but it's a lot of extra effort on part of the consumer. And also, when we're talking about cloud-based models like Azure, where you're being charged on metering based on usage, it can be more expensive because you would have a number of poll operations that actually don't pull any data, and you could be wasting money that way. Event-driven integration means that there's a possibility of pushing that data out when it happens, and therefore could be not only more timely, but also save costs. And finally, in mentioning the publish and subscribe model, one of the benefits of that model is the fact that you can extend the model, like say if you want to add new features, by adding additional subscribers to events that are already being published. And that has no impact on the existing subscribers, and it requires no extra effort usually on part of the publisher. So it's a very flexible and scalable model. Now, I did want to talk briefly about the difference between messaging and eventing. Here, I'll kind of speak through this, but I normally go through this discussion about three different kinds of messaging models that we're used to. And the pizza analogy is always a very effective one to do it. And the fact that it's lunchtime here in Queensland right now, I'm staring at that pizza, it's making me very hungry. So if you want to order a pizza, there's a few things that you need to know first. You need to know if the pizza shop's open, and you need to know what kind of pizza that they have. Now, that information is normally readily available. You can phone up the pizza shop and get your answer, or you can just go to their website and get that. But typically, this is a synchronous type of model where you make the request and you expect to get your answer straight away. It should come quickly, and it shouldn't take very long to produce that answer. That works really well when you have that kind of a scenario. It's simple to build. But once you order your pizza, you don't normally expect to get that pizza handed to you straight away. If you do, it's probably not a really good pizza. It's probably been sitting under a heat lamp somewhere. So what would normally happen is they would take your order and they say, okay, that's fine. It'll be ready in 20 minutes. Now, the interesting thing is there's two different ways that you can retrieve that pizza. One, which is usually the preferred method, is you get them to deliver it to you, especially preferred right now with coronavirus. So that means that you place the order, and then while that pizza is being made, you can do other things. You can sit and watch TV, you can have a beer, you can chat to your friends. It's the pizza shop's responsibility to make sure that that pizza is delivered to you when it's ready. But in order for them to do that, they need something. They need to know your address. So in the IT world, we would call that a callback URL that you'd have to give them. So, and sometimes, while that seems a preferable way to do things, it can be tricky. If you're sitting behind a corporate firewall, it may be difficult for you to open up an endpoint for somebody to be able to deliver that. So hence we have the second type of model, which is where instead of having them deliver the pizza to you, you go and pick it up yourself. Now, typically they tell you the pizza is going to be ready in 20 minutes. You get to the shop in about 10 minutes, and you go to the counter and say, "Is my pizza ready?" And they say, "No, it's still cooking." So you have to sit down and wait. You're smelling all the lovely aromas of the pizza's cooking. And in about 5 minutes, you get up and say, "Hey, is it ready yet?" And they say, "No, it's still cooking." So you sit down again, and now your stomach starts growling, and you're getting very impatient. And finally, go up to the counter and say, "Is it ready yet?" And they say, "Hey, yep, it's coming out of the oven now." So that's an example of polling, right? So this means that the consumer has to keep asking for when that information is ready and retrieve it itself. It's simpler on part of the service provider, but it does take more effort on the part of the consumer. Now, the third model is when you decide the pizza is really, really good, but it's quite expensive. So you ask the manager, "Can you please notify me when you've got specials on those pizzas so that I can order them?" And the manager says, "Sure, I'll put you on the mailing list." Now, the interesting thing about this, and I kind of mentioned this before, is that when the manager creates his newsletter, he only does that once, and he pushes it out to his distributor, whatever that might be. It could just be an email distribution list. The point is, there's no extra effort for him, whether that list grows or shrinks, it matters not to him. Well, from a business perspective, it might matter if it shrinks too much. But essentially, there's no additional effort, and he doesn't even necessarily know who's consuming it. We call this publish and subscribe, and we like that very much in the integration world because it is very, very flexible. It's completely decoupled. It's very scalable. It is generally the best model that we use for those reasons. It also happens that these three different maps to the three different types of service interaction you may be familiar with, which is command, query, and event. Now, I don't know how many of you know who Clemens Vasters is, but he is the genius at Microsoft who basically designed Azure Service Bus. And he's an incredibly intelligent guy, and he gives incredible presentations. They get very, very deep, usually, about 3/4 into his presentation, my head's spinning. But they're really fantastic topics about messaging and eventing. I've given a link here to one of his presentations he did a couple of years ago where he talked about the difference between messaging and eventing. And I liked it so much that I stole it. So Clemens says that messaging is basically about intents, that there is an expectation on the part of the publisher that something is done with that data, with that message that's being sent out. And for that reason, those interchanges might be conversational, right? There might be some back and forth between the participants in that. It could be transferring control or maybe just pushing out data to another process that needs it to do something. Eventing, by contrast, is more about just broadcasting facts. And in this case, the publisher not only doesn't typically know who's consuming it, but doesn't even really care. There's no coupling at all here in the processing of that. And if it's series-based eventing, the order and sequence might be important. And rather than having a contract and messaging like you would to make sure that everyone knows how to consume that information, eventing, there may or may not be any kind of schema involved. I'll talk about schema shortly. So from a graphical perspective, when we look at the communication patterns, for messaging, as I said, is kind of conversational. There'd be a bit of back and forth here. And the participants generally know who each other are. Whereas in eventing, it's very one way. And the publisher typically doesn't know who the consumers are. I mentioned about schema before, and there's an organization called the CloudNative Computing Foundation that has been working for a number of years to create a standard specification for describing cloud events. And they succeeded in getting to version 1.0 several months ago. And this is what it looks like. Here's an example. You can see that this is some JSON. And some of the typical features of it, first, it tells what version of the schema that we're using, so you know how to interpret it. But then every event has these three types of metadata associated with it. There's the type of the event, which in this case is a pull request. There's the source, which is where it's coming from, who's actually publishing the event. And then the subject, which gives you a little bit more fine-grained detail about that. In this case, the 123 probably is a pull request identifier. Every event also has to have a unique ID and a timestamp. And this is how you distinguish one event from another of the same type. Then, of course, you have the payload. Now, the payload is meant to be pretty lightweight. Remember, this is only about sending metadata, not huge amounts of data. And the data content type tells you how to read it, which in this case is XML. There's also provision in the schema for a couple of extensions in case you have additional properties that you want to publish with the event that you don't want to put necessarily in the payload. So now I get to talk about Azure Event Grid. So Event Grid is one of Microsoft's solutions for eventing. It's an extremely powerful feature that is built into Azure, and it allows you to have that asynchronous and decoupled process for being able to publish and react to events that happen within and without the Azure platform. So it's a publish and subscribe sort of system that supports intelligent filtering and routing capabilities. It is a push model, and this is very different from Azure Service Bus, where I talked about polling before, where you publish to a queue or a topic, and then the consumers have to pull those messages off. Azure Event Grid actually pushes notifications out to its subscribers. So it's a very, very efficient process. And it's built into a whole lot of Azure services. So if you look at this slide on the left side, and this is probably out of date now because they keep adding services all the time to it, you can see that there's a whole lot of components and features in Azure that actually automatically have the ability to publish events to Event Grid. Also, if you look at the last two, on the bottom two on that left side, you'll see that it supports cloud events, which I've already mentioned, and custom events, which means that you can react to events outside of Azure as well. It takes a little bit more work because you have to write the code to actually publish it, but you're capable of doing that through Event Grid if you want. And then the event handlers, again, a whole lot of Azure services that are able to react to those events and use them. But if you look at the bottom part of that screen, you'll see that webhooks are there. And basically, webhooks means that you can publish these events and manage and react to them from anywhere, not just within Azure. It is extremely reliable and performant. So their aim here is to have sub-second latency in 99% of the time for events that go out. And it's massively scalable. Event Grid for each Azure region is designed to handle 10 million events per second. So that's really quite a lot. And it's also very resilient because it will retry pushing those events out to the publishers if it doesn't succeed the first time. And it will keep doing that for 24 hours. And it will use an exponential backoff on that, so it doesn't keep pushing it out at the same time. And it's even clever enough to randomize that exponential backoff for each event a little bit so that you don't get just a continuing a rolling window of saturation if the service is down. The benefits, obviously, is that because you don't have to write any code to do this, you can connect these applications and focus on innovation. The cost is you pay per event, as you might expect. It's very, very reliable and performant, and enables you to build new scenarios, and most importantly, allows you to manage your events in one place in Azure. Now, when I talked about those really high numbers before, these are a bit outdated. They were over a year old because my contact at Microsoft that gave me these numbers no longer is there. But basically, Event Grid has been designed to be able to support 2.2 trillion requests per day. And that's really the kind of numbers that they were getting a year ago. And with that, they were meeting almost 6 nines of a success rate. But the problem is when you have numbers that big, what does 6 nines really mean? And that's what it means. That even so, that's 4.4 million failures that they get. The reason I point that out is as resilient as Event Grid is, you still need to design your applications to be able to handle those occasional failures. So some limitations for you, 64 kilobyte message size limit. Now I think that's been increased recently up to a megabyte. But generally, the idea, again, notifications in eventing should be lightweight, not full weight. If the consumer needs more data, the event notification should give them the information they need to retrieve more data. There is no sequencing of events. It's just accept the event and push them out straight away. So this would not handle series-based eventing very well. There's another product in Azure that would do that better, and I'll talk about that soon. There's no ability to replay events. So for event sourcing, probably this is not the solution for And I mentioned already about the one-day time to live. If you can't publish within 24 hours, there is the ability to enable a dead letter queue, so you can still persist those events that don't get delivered. From a security perspective, so publishing, if your security is already built into all of the Azure event publishers, but if you're publishing from a custom source outside, you have a choice of using an AEG SAS key header or a SAS token, which is the preferred method. Within Azure itself, everything is controlled by RBAC. So that means in terms of creating the subscription and managing the event grid as well, all controlled by RBAC. Here's an example of an event. So this one is a blob event. And if we look at the data part of it, we can see that this is a blob being created. And it's given you just the amount of metadata that you need to know how to access that blob and what the significant features of it, like its size and its content type. It doesn't give you the data itself in that blob, because that's not what an event notification is meant to do. But you also see above that the standard metadata things, the topic, the subject, the event type. These are similar to the cloud event samples that I showed you before. And I just wanted to mention also about event domains. So it may be that if you're publishing events to multiple customers and you want to be able to segregate those customers through Active Directory spaces, through different tenancies, you can do that through event domains. Now, there's a number of different services that handle eventing and messaging in Azure, and trying to determine which ones you should use can be tricky. So basically, at a very high level, Service Bus is what you use for messaging, for data, and where it's extremely important to get that information across, like when you have transactions involved, for example. Service Bus is a very full-featured messaging platform. It supports transactions, it supports deduplication, message forwarding, all kinds of features like that. Event Hub is your event ingester, and that does have the ability to replay messages. So if you're doing event sourcing, or if you're doing series-based events, Event Hub might be your ticket, because it can actually do that context-based partitioning. Event Grid is really about pushing notifications out and building reactive applications, and it's a push-push model, unlike the other two. So with all that, I've got about 12 minutes left, actually, a little bit less than that. And I've got a couple of demos to perform. I might go ahead and do this one. So this is this demo here is just to show how quickly and how easy it is to build a solution using Azure Event Grid. And all I'm going to do is I'm going to react to files that are created in a storage blob and send them out to 2 different notifications based on a subscription. In the interest of time, I might only do one of the subscriptions because I did lose a little bit with the audio problem, but you'll get the idea. So with this, you should see my screen now. This is a storage account that I have created in Azure, and that storage account has a single container in it, which at the moment, I'll just go to my Storage Explorer. That container right now is empty. What I'm going to do is in the storage account, if we go to the Events tab, in there, I can actually create an event subscription based on this. And all I have to do is add event subscription. And this will use Event Grid. So I'll give it a name. So I'll call this GAV demo JPEG. Sorry, JPEG. Okay, and I have the choice of using different schemas. I can use the built-in Microsoft schema for Event Grid, or I could use Cloud Event if I wanted to. I'll just go with the Event Grid schema for right now. And then based on this storage account, you can see that there's multiple different things, events that I can track and react to. So for a moment, we'll just go with blob created right now, but I could respond to multiple events if I wanted to. And then I have to choose what I want to do. Where is this going to be published to? And you can see I have a bunch of different choices: an Azure function, a webhook, a storage queue, event hubs. I'm just going to choose webhook because it's one of the easiest things to do. For this, I need to give it an endpoint. And I'm going to use my old friend request bin here because it's easy to see when a message arrives. So I'm going to click Create a Request Bin. And And that's going to hopefully come back. Yep. Oh, okay. We'll copy this, that URL. I'm going to go back to my workbook and paste that in. Okay, and confirm that. Okay, then I can go and create my event. But first, I want to go through and note there's a couple of other features I can add. So I can enable subject filtering on this. So in this case, you can choose a subject that begins with or ends with any particular phrase. So I'm going to put .jpeg on this because I'm only interested in JPEG images that are created in this container. And I can even choose if I want that to be case sensitive or not. I could also add advanced filters based on properties that I expect to be in the message if I want to. Other additional features I could do, I can enable dead lettering. I can configure my retry policies. There will be a default retry policy, but I might want to limit that, for example, and say I only want you to retry 3 times instead of 10 times or whatever. And a few other things that I can control. But right now, I'm just going to go click Create. And when I click Create, this is going to create the first event. And that event is basically a subscription validation event. So if you can see this, I've got some JSON here, and if we look at this, we can see it's a subscription validation event, and this is just Azure Event Grid making sure that that URL that I've given it is correct and can actually respond. Now, the next thing for me to do is simply to create an event by publishing a file. So I'm going to go ahead and drag a JPEG into here and in Storage Explorer and create that image. That should upload pretty quickly because it's not a very big file. It seems like the internet's a bit slow. There it is. Okay, and if I go back to my request bin, I should get a new event in there. And I do. So we have this event here that's been created. Now, it doesn't format the JSON really well, so I'm going to copy that, and we're going to use our friend Visual Studio Code to kind of format that. I think it's here we go. Okay, so now you can see what this looks like, and you can see it's a blob created event. It gives the path to my image, and there it is, dan.jpg that I popped in there, and a bit of metadata about it. Now, if I were to go back into my Storage Explorer and copy another file, let's say a PDF like this one, it would not generate an event because there is no subscription that's responding to PDFs because I had a filter based on the JPEG. So I'll just go ahead and refresh this again. And we'll see there's no new event created. Okay, I could build another subscription for PDF, but I think in the interest of time, I'm not going to do that at the moment. So we'll go back to our slideshow, and I see that I've got about 7 minutes left. And I really want to show you this demo because it's much more impressive than the other one. This one is kind of more of a real world situation. So if you can imagine that I'm a developer at a company and I'm given a virtual machine to develop with, but I'm getting impatient with how long it takes for things to compile. So I decide I want to I want to scale up this machine to make it more beefy. So when I do that, that creates an event in a resource group. Now, Event Grid can respond to that, and using a logic gap, because the event doesn't actually contain the name or the size of the VM, it gives the name of the VM, I have to go back and query from the resource group what the new size of that machine is. So I call the logic gap, which runs a workflow, calls an Azure function that goes and retrieves that size. Then it goes and looks up at a table, and the table contains a number of allowed sizes, the sizes that my manager says that I can use that won't break the budget. And based on whether that size comes back as to being an allowed size or not, an email message is sent to my manager, who then, if he finds out that I'm actually extending my machine beyond what his budget allows, will come and slap me on the backside of the head and make me change it. So this is the demo I want to show you. I'm not going to build this now because obviously there's too many things, so I built it previously, and we'll show you that in operation. Here is my virtual machine. You can see that right now it's a DS11, which is an allowed size, but I'm not really happy with the 14 gig of RAM. I'm going to decide I'm going to make this DS12. So I'm going to go ahead and resize that machine. Now, while that's running, and it takes a couple of minutes to do it, I'm going to show you my logic app. My logic app basically triggers when a resource event happens in that particular resource group, and it's a write success. Then there's a condition to see whether that write is based on a virtual machine or not, because anything else could change in that resource group, including the actual event topic itself that I created to monitor this. So only if it's a virtual machine do I continue. Otherwise, I just cancel out of the process. Then I need to call an Azure function, which is going to go and get the virtual machine size based on the path to that virtual machine that was passed in the event. And then it does a lookup into with another Azure function that goes to an Azure table storage and determines whether or not the machine is one of the approved size. And depending on whether it is or not, it will send a notification email. If it is an approved size, then it just sends nothing more but a notification email with low priority. But if it isn't an approved size, now it sends an alert email with a high priority to my manager to say, hey, you better change it. Right, so I've changed that machine. So now if we go back to here, and this is the screen, let me just refresh this. We should see that this process has run recently. Not yet, still waiting to be triggered. And also I'll show you the email account that I'm using to monitor this, which at the moment has no new messages. Now it does take sometimes, did I actually resize it, or did, actually I didn't hit resize, did I? Resize, sorry about that. I thought I'd done that. Okay, it's resizing the virtual machine now. That will only take a few seconds because the machine's not running. And then hopefully we'll see the events be generated from that. So it's resizing now, and that should succeed any second. There it is, that succeeded. Okay, so we can monitor this to see when the event is created. There it is, it's running right now. So I can actually go into this and look at the process that's running, and we can see it's already made its way through the first two steps, and it's in the process of running the others. When that completes, and it looks like it's just finished, you can see the green check marks in here. So it's checked the approved size. It's sent an alert email because it's not an approved size. So if I go back to my mail, I now have a message in here that tells me that an unauthorized size has been set. And you can see that I was able to get the metadata of that particular machine and where it exists from the event notification itself. So there is an example of a real-life type of application. So I'm about to lose the meeting, so I'm going to continue with this. Just in summary, event-driven design allows for cost-effective, real-time response in your applications. We talked about the difference between eventing and messaging, and that EventGrid is a serverless solution for easily building event-driven solutions in Azure. If you're interested in attending some monthly webcasts that we have in Australia, you can go and check this out. It's in an Australia-friendly time. And if you want to connect with me, that's how you connect. So I'll leave this up here so you can get that QR code. And I promise I will look at the chat screen and try to respond to your messages. Send me a LinkedIn request. I think this meeting is going to end in just a few seconds. So I'll briefly have a look and see if there's anything on the chat. Okay. All right, good. I don't see too many questions in the chat. So again, thank you very, very much for attending today. Feel free to reach out to me on LinkedIn or on Twitter. And thank you for joining this session for Global Azure Virtual Bootcamp.